we are looking at the eigenvalues and eigenvectors for 3 by 3 matrix. Okay, and we have the question here: find the eigenvalues and eigenvectors of this matrix. Okay, and the question, we have 3 by 3 matrix. In the solution, I'll be itemizing the step-by-step approach to get the eigenvalues and eigenvector. Step 1. Step 1, get the what? Get the characteristic equation. Okay, and that equation is 0 equal to det, which is the determinant of this matrix. Okay, that's that. Then let's write this equation in this characteristic equation. That will be equal to, you can also write this equation in this form. You can write this equation in this form as determinant of A minus this equal to what? Equal to 0. Put brackets here, equal to 0. They are the same thing. What this means is that the matrix A, we have it is 1, 2, minus 1, 1, 0, 1, 4, minus 4, 5. That's my matrix A. And then we have here minus what? R. Okay, where the R is what? The R is the eigenvalues. Okay, then R times the I is the identity matrix. An identity matrix for 3 by 3 will be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, is only the main diagonal that is 1, while the middle element is 0. That will be, when you multiply this R, this eigenvalue, by this, all that will be still be 0 except the main diagonal, which will be R, R, R. So then the determinant is this symbol. Okay, equal to what? Equal to 0. So 1 minus R, that's what I could have it. 2 minus 0, that's what? 2. Minus 1 minus this, that's minus 1. Here also will be what? 1. Here will be what? 0 minus what? Minus what we have here, which is R. That's what? That's minus R. And then 1 minus 0, that's 1. Here will be what? 4 minus 0. Here also minus 4. Here also 5 minus R. So we've finished with this characteristic equation. Then the next thing is to get the determinants, whereby at the end of the day we get the eigenvalue. Okay. So in doing determinants, I'm going to use the row 1. I'm using the first row to do my evaluation for the determinants, which will be the first element here on the row 1. I'm going to take it out, cover it vertical, cover it horizontal. So what you have left, you have the determinant of what? Minus this, 1, minus 4, 5 minus R. Here you have 2. Don't forget your cofactor sign, plus, minus, plus, for that first row. So that would be what? Times what? Times minus. So minus 2 into bracket what? Cover this vertical, cover this horizontal. So you have 1, 4, 1, 5 minus R. Then the final one, that's a minus 1. Do the same thing. So cover it horizontal, cover it vertical. So that will be 1 minus R, 4 minus 4. So that's what we have there. 1 minus this. This will be this one times this one. That's minus R into brackets. 5 minus R. That's minus what? When you are doing determinant, once you do this one, you multiply this, then you multiply this also. That will be minus 10. So that will be plus 4. Plus 4. The second one, minus 2 into brackets. This one times 1. That's a 5 minus R. Then minus what? This one times this one. Minus 4. minus 1 to bracket what? This one times this one, that's minus 4. Then minus 4r, that's 4 plus 4r. Okay, so we now have this minus this one times this one, minus 5r. This one times this one plus r squared, then plus what? Plus 4. Minus 2 into bracket 4 minus 5 minus 4, that's 1 minus, that's 1, then minus r. Then minus 1 into brackets minus 4 plus 4r. That will be equal to 1 minus r into brackets r squared. Do the arrangement of this one, minus 5r plus 4 plus 4. Then minus 2 times 1, minus 2 times this one, plus 2r, plus 2r. This one times this one, plus what? Plus 4, then minus 4r equal to 0. Here also is equal to 0. So we now have 1 minus r. This one is quadratic. We can factorize that. R squared. Factorize that. We can pair the r squared into 2, 1 here, 1 here. Factors of 4 that can give you minus 5, either by adding up or by subtracting. That's factors of 4 is 4 and 1. So how do you use 4 and 1 to get minus 5? That will be minus 4 minus 1. And when you multiply minus 4 and minus 1, you get back the plus 4. Okay, so that one is done. Then here, minus 2 is here, plus 4. Minus 2 plus 4, that's a plus 2. Plus 2. And then this one, plus 2r minus 4r. That's minus 2r equal to 0. Okay? So, another line, this one, and then this one. Here, you can take 2 out. That's a plus what? Plus 2 into brackets 1 minus r equal to 0. So that's all we have. Then the next thing to do now, we can factorize this. 1 minus r is here, 1 minus r is here. So take that out, factorize that, and that will be equal to what? R minus 4 into this one, r minus 1, then what? Plus what? Plus 2 equal to 0. Okay, that will be 1 minus r into brackets. Let's expand this. This one times this one, that's r squared. This one times this one, that's a minus r. Okay, then this one times this one, that's minus 4r. This one times this one, that's plus 4 plus 2 equal to 0. So 1 minus r into brackets r squared. This one and this one will give minus 5r plus what? Plus 6 equal to 0. Plus r brackets r squared is here, pair it. Factors of 6 that can generate minus 5. So that will be minus 3 minus 2 equal to 0. So this one implies 1 minus r is equal to 0, or r minus 3 equal to 0, or r minus 2 equal to 0. So if you solve this one, r is equal to what? 1, or 3, or what? Or 2. The eigenvalues. The eigenvalues are 1, 2, or 3. So these are the 3 values. The eigenvalues are 1, 2. The values are 1, 2, and what? And 3. Yeah. To find the eigenvector, corresponding to r equal to 1, then we use this equation, this expression. So we use this expression to calculate the eigenvector for r equal to 1. So what we do, this equation means that just come here. You can see your eigenvalue. How is your eigenvalue, which is 1. So come back here. The leading diagonal, this is 1 minus r. This is 0 minus r. This is 5 minus r. So which will become 1 minus 1, that's 0 there. Then 2 minus 1. And then here, 1. 0 minus r, that's what? 0 minus 1, that's minus 1. 1. Then 4 minus 4. 5 minus 1, that's what? That's 4. Okay? That's the meaning of this r minus I. Okay? Then, this one, the vector component of this will be u1, u2, and then u3, because it's 3 by 3. Then equal to this also is also a vector. The component will be 0, 0, 0. So that's what we have for the for that. Then the next thing to do now is to get the augmented matrix. Get the augmented matrix, and that will be equal to 0, 2, minus 1, 1, minus 1, 1, 4, minus 4, 4, then augmented matrix 0, 0, 0. Okay, so when you are doing your augmented matrix, this place is going to be removed, and you combine this. Don't forget we said that this is what you combine this with this. Okay, so we have this. Then the next thing to do now is to do the row operation. And what we want to, if you look at this equation, it's far better to have 1 here. Okay, the starting point is must be 1, so to make the row operation to be more easy for you. Okay, so I'm going to interchange. I'm going to swap row 2 with row 1. This is a symbol for swapping. That's the first thing I'm going to do there. Then I'm going to have now, when you are swapping, you are moving this row 2 to row 1, and then row 1 back to what? Row 2. So you have 1 minus 1, 1, 0, then row 2, row 1 here, coming to row 2. So that's that. Then the next thing to do now, that will be, we've already have 0 here, which is making sense. The first element here, well, let's try to see. Let's make it also 0 also. And it's also possible to have 0, 0 here too. Okay, so this is our focus here. This is 4. This is what? This is 1. So what I'm going to do is going to be row 3 is equal to row 3 minus this one times 4. Row 1 times 4. 4r1. So with that now, I'm going to have 1 minus 1, 1, 0, 2, minus 1. 4 minus 4, that's 0. This is minus 4, minus 4, minus from here, this minus here, and then times 4, that's minus 4. That's also 0, 2. Then here, 4 minus 4, that's 0. Okay? Your augmented matrix, 0, 0, 0. So that's what we have now. Then the next thing we'll do now, don't forget, this first column here is for row 1. It's for u1. This is u2, u3. So the second row, that will be 0 times u1, that's 0, and then 2 times u2, that's a 2 u2. Then what do you have here? Minus 1 times u3, that's minus u3, equal to what? Equal to 0. So in that case now, u3 is equal to what? u3 is equal to, you should move this one to the other side. So u3 is equal to 2 u2. Okay? Come to the first row. So 1 times u1, that's u1. Then minus 1 times u2, that's minus u2. And then 1 times u3, that's plus u3, equals what? Equal to 0. So we can make u1 the subject. So u1 is equal to And move this one to the other side. That's u2 minus what? u3. So u1 is equal to what? u2. We have the expression for u3, which is what? Which is minus 2u2. So this will give me minus what? Minus u2 as u1. So then the next thing to do, is to consider u2 as x. So in that case now, u1 is now what? Minus what? Minus x. And then u3 will become what? u3 is what? u3 is 2x. Okay? So therefore, then we now have the vector which has a component of what? u1, u2, u3. We have the value for that. u1 is what? Minus x. It is x. And then u3 is what? 2x. So, and that will be equal to, you can take the x, you can take it outside, then we have minus 1, 1, and 2. So that's what we have. Minus 1, 1, and 2. Okay? Therefore, we take minus 1, 1, 2 as what? As eigenvector. Eigenvector for r equal to what? For r equal to 1. Okay? So what that means literally is just that we just make this x to be equal to what? To be 1. Literally. So but that's what we are taking as what? That's the eigenvector for r equal to what? For r equal to 1. So then the next thing to do now, eigenvector for r equal to what? For r equal to 2. Let's get that because we have three values for the eigenvalues. We have r equal to what? 1, 2, and 3. So we've gotten the eigenvector for r equal to 1, and we have to repeat the process also for r equal to 2. So let's go straight to that. So that will be equal to, the formula will be equal to a minus 2i. Okay, this vector equal to what? 0 vector. Okay, then don't forget this originally, this is what? A minus ri. Okay, this is your vector component, this is your vector, and this is your eigenvector, and that's what we are looking for, equal to 0. And we already know with for this case now, r is 2. That's why we have 2 here. So this will now give us, what we just do is just very simple. We just go back to our matrix and then begin to subtract 2 from the main diagonal. And that will be equal to what? 1 minus 2, that's minus 1, 2, minus 1, then 1, then 0 minus 2, that's minus 2, 1, 4, minus 4, and then 5, minus 2, that's 3. And then for the vector, the component will be what? u1, u2, u3. Okay, this 0 also is also a vector. The component will be what? 0, 0, 0. The next thing to do is to get the augmented matrix. Okay, and that will be equal to, in that case now we are combining this 3x3 matrix with the 0 vector. Okay, and that will be minus 1, 2, minus 1, and then the second one here, 1, minus 2, 1, 4, minus 4, 3, then 0, 0, 0. So that's the augmented matrix. Now, as I've said, the first element here, that start the main diagonal, it must be 1. So it makes the row operation to be easier. So we're going to swap row 2 with row 1. Okay, we're going to swap that. And don't forget, this is a symbol for this is a symbol for swapping. Okay, what we are doing in this place is that we're moving row 2 to row 1, and we're moving row 1 to row 2. Okay, and that will be 1 minus 2, 1, then minus 1, 2, minus 1, then 4, minus 4, 3, 0, 0. So that's what we have done now. So then the next thing is just to look for way to make this to be 0 and this to be 0. Okay. So in that case now, we can now say root 2 is equal to root 2 plus what? Plus 1. If you add it together, we have 0 here. And likewise also, we can get root 3. Root 3 will be what? Root 3 minus what? 4 times what? 4 times root 1. Okay. So in this case now, row 1 is not changing. It's just a reference point. Row 1 is not changing. It's a reference point. 1 minus 2, 1, 0. This plus this, 0. Minus 2 plus this, 0. Minus 1 plus 1, 0. 0 plus 0, 0. 4 minus 4 times 1, that's 0. Minus 4 minus this one times 4, minus 8. So that's 4. And then 3 minus this one times minus 4. That's minus 1. That's minus 1 here. Okay, 0 here. So that's what we have there. Then, so what we now do now, go to your row 3. So we can have row 3 will be, don't forget, vertical down is for U1, second column U2, third column U3. So which implies that 4 times U2, then minus 1 times U3. That's minus what? Minus U3 equal to 0. Then that will be U3 equal to what? 4 U2. Okay? Then let's go to the first row, and that will be U1 minus 2 U2, and then 1 times U3. That's the plus U3 equal to 0. So in that case now, we can make U1 the subject, move this one to the other side. That's 2 U2 minus what? U3. That's 2 U2. U3 is what? Minus 4 U2. And that's equal to what? Minus 2 U2. Okay, so let's consider U2 to be this. Okay, so if we do that, then we now have the vector. We can call this the second one. That's the second eigenvector will be equal to U1 is what? U1 is minus 2x. Okay, minus 2x. U2 is x, and then U3 is what? 4x. And this is equal to what? Take this x out, then you have what? Minus 2, 1, 4. Minus 2, 1, 4. Minus 2, 1, 4. So we take what? We take minus 2, 1, 4 as eigenvector. As eigenvector for r equal to 1, for r equal to 2. Then finally, to calculate eigenvector for r equal to what? 3. So, and that will be equal to a minus what? 3 what? 3I equal to what? Equal to 0. This line is just a vector, it's an arrow. So that's that. And that will be equal to, come to your main diagonal. Everything you have there, that will be minus 3, minus 3, minus 3. That is the meaning of this. Okay? So that will be 1 minus 3, that's minus 2, 2 minus 1. And the second one, that will be 1, 0 minus 3, minus 3. 1, 4, minus 4. And then 5 minus 3, That's 2. Then the vector component of this, that will be u1, u2, u3, equal to what? Vector component of this, that will be 0, 0, 0. Okay? Then the augmented matrix. Augmented matrix. Augmented matrix, that will be minus 2, 2, minus 1, 0, 0, 0. Then 1, minus 3, 1, 4, minus 4, 2. So that's the augmented matrix. Then the next thing to do is to do the rows, to swap the rows. Exchange row 2 with row 1. Okay? And that will be what? That will be 1, minus 3, 1. Then moving row 1 to row 2. Minus 2, 2, minus 1. And then 4, minus 4, 2. So without wasting time, row 2 will be equal to row 2 plus what? 2 times row 1. And then row 3 will be equal to row 3 minus 4 times row 1. Because I want to ensure that I have 0, 0 here, I have 0 here. Okay? And that will be equal to row 1 is a reference point, it's not changing. Okay? Minus 2, this one is times 2. Minus 2 plus 2, that's 0. Here, 2 minus, this one times 2, minus 6. Okay? So that will be 2 plus 6, that's 8. Here, minus 1. Here, that's 2 plus 2 plus, this one times 2, that's a minus 6, so it is minus 4. That's minus 4. And then minus 1 plus 2, that's 1 here. Okay? 0 plus 0, that's 0. Here, 4 minus 4, that's 0. And then minus 4, that you have here. Then minus, this one times 4, that's minus 12. So this will give us what? This will give us 8 here. Then 2, the one here, minus 4, that's minus 2. So from row 3, we can use either of these two. You can use row 2, you can use row 3. From row 3, so we have 8u2 minus 2u3 equal to 0. So, and that will be 2u3 equal to what? Minus 8u2. Okay? 2 here 1, 2 here 4. So u3 is equal to what? Minus 4u2. We have 8u2 equal to what? 2u3. Okay? 2 here 1, 2 here 4. Okay? So u3 is equal to 4u2. u3 is equal to 4 u2. Okay? We need u1. So let's go to row 1 so I can have u1. Okay? Because from row 1, that will be u1 minus 3u2 plus u3 equal to 0. So u1 is equal to 3u2 minus u3. Okay? Then we have value for u3, and that will be equal to 3u2 minus u3 is what? 4u2. And this will give me what? Minus u2. That's for u1. So consider u2 to be this. Okay? Therefore, we have the vector, the eigenvector for r equal to 3. That will be equal to, my u1 is what? My u1 is minus what? Minus x. Okay? Because u2 is what? Is x. u2 is what? Is x. And u3 is what? For what? For x. And this will be equal to, you can factorize the x, you can take it out. That will be what? Minus 1, 1, 4. Okay? So we take what? We take this one, minus 1, 1, 4, as what? As eigenvector. As eigenvector for r equal to what? For r equal to 3. And that is the end of the question. Please, if you are new on this channel, please smash that notification bell so that you can keep track of the updates of this channel. Okay? Click on like button and then begin to make your comment now.